Recording in progress. Recording in progress.
अस्सलाम वालेकुम रहमतुल्लाहि व बरकातुहू.
Walaikum assalam.
Okay. Now we will discuss about the next topic, that is about distribution. Can you okay. Is my screen visible? Are these notes visible to you? Can you hear me?
Yeah.
I'm asking, are these notes visible?
Yeah, I can see the.
Okay. क्या
पढ़ा रही है बाजार से रोटी मंगवा लो हैं वरना तो छिलकों वाली बनेगी
नहीं इनको कह रहे पापा. Okay, sorry. Now we were discussing about the distribution of mass and charges within the atom. We have discussed this earlier. Now can you tell me, can you describe what is the distribution of mass and charges within the atom?
Yeah.
Mm-hmm.
The mass is concentrated in the nucleus, and the electrons have negligible mass.
Yeah, that is why the electrons, they revolve in the orbits.
The protons have a positive charge, and the electrons have a negative charge.
Yes. And
the neutrons.
Why we are saying the mass is concentrated in the center?
Because the electrons have negligible weight, and
because we will say because the protons and neutrons mass is 1836 times more than that of the electrons. They are more condensed. They are heavier as compared to the electrons, and since they are present in the center, that is why the mass is concentrated in the center, because the heavier particles are concentrated in the center. That is why the mass, the atom's mass is concentrated in the center.
Yeah.
Okay. And
are you wearing headphones?
Sorry?
Are you wearing headphones?
I can't hear you. What you are saying?
Your voice is cracking.
Is this clear now?
Yeah, and I can hear myself in the.
This happens background. If you are you using hand frees?
What?
Are you using any hand free or AirPods?
No, I'm not using.
I don't know why it happens. It happens sometimes with some people. Even though when I take class in the morning in my Quran class, there are students. Whenever they open their mic, our teachers, my teachers say that don't open it, because she always get her voice back, just like you are saying. So
yeah.
Just whenever you have a question, unmute yourself at that time. Otherwise, I think you will get distortion. And I don't know why this happens, even though it happens in Google Meet and this happens in Zoom meeting as well. Sometimes.
It didn't happen in Google Meet.
Sometimes it happens over there. I prefer Google Meet over. Sometimes I prefer Google Meet, but you know, in Google Meet there is so much background noise. I can't record the videos. Whenever I have recorded, I can share my recording with you, and even though from your side there is so much noise, and from my side there is so much noise. That is why Zoom is preferable over the Google Meet.
Okay.
Yeah, we were discussing the distribution of mass and charges. So because the the heavier things are present in the nucleus, the protons and the neutrons, that's why the mass is concentrated in the nucleus. And why electrons revolve around in the orbit? What's the reason? Why the negatively charged electrons revolve around the nucleus in their orbit?
Because they're attracted to the proton charge.
Because they are too light. They are 1836 times, their mass is lesser than that of the protons and neutrons. That's why they revolve around the nucleus. Okay, now we have discussed about the atomic mass and atomic number in the previous video. You can see the in the previous section, and that if you see these all the elements over here, they have mentioned it right this like this. Okay, this is the image in which they have mentioned like this, but whenever they will give you, they will give you in this form, like this is boron. 5 will be written in the subscript and 11 in the superscript. Okay, so this will give you, what is 11?
That's the mass number.
And also mass number is also known as,
Atomic
no, mass number is
nucleon number.
nucleon number. Yes, mass number is also known as nucleon number, and this is known as proton number, and also what it is known as, proton
It's
number.
known as the atomic number.
Yes, atomic number. Okay, and it is represented by Z, and this is represented by A, capital A. Okay, now we are going to discuss about the behavior of protons, neutrons and electrons moving at the same velocity in the electric field. How we know, how it comes to know about the protons, neutrons and electrons, that they are charged particles, and they, like the proton have a positive charge and electron have a negative charge, and neutrons don't have any charge. How is this done? This was done by the scientists, and they perform experiments like this. This is a CRO. This is known as cathode ray oscilloscope. Okay, this is an instrument, cathode ray oscilloscope, in which they use the beam of electrons, and they pass that beam of electron by providing the different charges on these plates. This experiment is not included at in the chapter 1, but I am just giving you a general overview that how they perform the experiment. So this is a tube, just like the tube light. This is a glass tube, and it is known as the this side is known as the screen, and on this screen you can see the deflection. Okay, and over here if you see these two are the charge plates. On this plate there is negative charge, and on this plate there is positive charge. Okay, and this is cathode ray. This is the cathode ray. So the cathode rays are originating from this source. Okay, this is the lamp. I am just giving you an overview. This is a lamp. From this cathode rays will be passing. And what are cathode rays? Cathode rays are negatively charged rays. Okay, these are negatively charged rays. So what will happen with them? These negatively charged plates, when you see them, the cathode rays, if you see this electron beam, see this example, this is the electron beam, the negatively charged beam. What will happen? It will bend away from this negative plate. So this will this will confirm that this ray is negatively charged, and it deflected away from the similar plate, because we have discussed it earlier that the same charges repel each other. So you know this is a negative charge plate, obviously it will repel the electrons, right? When it will repel, what will happen?
It will go down towards the positive.
Yeah, electrons will move, and this will repel, and this plate will attract. Okay, so there will be bending like this. Okay, and this will be a quite observable bending. It will be a much higher bending. You can say this will be a very large bending. This will tell you that the electrons are very small. That's why the bending is more. You see, whenever you have a heavier mass, the bending is less. Whenever you have a heavier mass, there is less fluctuation, there is less flexibility. But whenever you have lighter things, you can easily push them, right? So electrons, one thing is that in this electron beam, it deflected away from the electron, and second thing is that this deflection was much larger, and this confirmed that these were the negative charge
Negative
electrons, right?
Yeah.
Okay, whenever we talk about this, we will say that whenever you have a beam of electron, it will be deflected towards which side it will be deflected?
It'll be deflected towards the positive.
Towards positive plate, away from the negative plate. Okay, and this is one point for the conformation of the electrons. And second thing is that what I told you. What is the second thing which confirms that they are very lightweight? The electrons are having very less mass. Large deflection. Deflection is very large.
Okay.
This large deflection tells us that they are very small. The electrons are very small. Okay, it indicates electrons are very small. Okay, now when we talk about the positive, a beam of proton, if you have beam of proton, what will happen?
It will deflect towards negative plate.
Yes, deflected towards negative plate, and large deflection.
And it is
Or what type of
not
deflection is
that,
it?
not
There
that
will be
large
smaller deflection. Why?
because it's heavier.
Because protons are heavier. It indicates that protons are heavy. Okay, and whenever we talk about the neutrons, as you know, the neutrons are they don't have any charge. They are neutral, so there will be no deflection. Okay, so when you talk about the neutrons, but how you will know about the mass of the neutron?
The mass of the neutron
Hmm.
by subtracting the proton from the nucleon number.
By comparing it with the proton, the relative masses, that is this formula, this we have done just to calculate the number of protons, not to calculate the mass. Okay, this is for number of protons. Over here I am asking you how you will know about the mass of the neutron, because this experiment cannot tell you the mass of the neutron. Can this experiment tell you the mass? This cannot tell. This just tells you the deflection and how much the deflection is, the magnitude of deflection. Is the deflection large or small? This experiment is telling you these things. It cannot tell you that what will be the mass of the neutron. We have summarized the masses by their deflection, by the large deflection for the electrons and protons. But for neutron, what can we do?
You said compared to
Yeah, we will compare
the proton.
it with the proton, because we have discussed it earlier that the masses of the protons and neutrons are almost
The same.
Yes. No deflection. Okay. And we will say that mass of neutron is similar to the mass of proton. Clear?
Yeah.
Okay. So this was about the behavior of the proton, neutron and electron. And remember one thing, that these these are moving with the same velocity in the electric field. This is the electric field. How this is the electric field? This one, this is known as electric field. That you have two different plates. You have attached them with the different terminals of the battery, and from one side there is negative charge, and from the other side there is positive charge. Okay. You have two electrodes, the anode and cathode. So in the electric field, with the same velocity, at the same velocity you are checking the behavior of the electrons, protons and neutrons, how they behave and how they differ. Clear?
Yeah.
Okay. Now we will determine the number of protons, neutrons and electrons in atoms and ions. We have done examples for atoms. Now we will do for ions as well. One more, we can do some example for atoms, and then for neutrons as well. Okay, let's take example from here. Yeah. 51 and 121 antimony. This is antimony. You see, its symbol is different as compared to its name, SB. Now what can be A for this? Z,
121.
electron and N. 121. Okay. What is A? What was A?
Atomic number. No.
Yes.
Mass number.
Mass number. Mass number or nucleon number.
Yeah.
What is proton number for this?
51.
Okay. What about the electrons?
51.
Protons? Not protons, the neutrons.
Neutron is 70.
70. Okay. Now I am writing the statement and determine the number of determine the number of protons when an unknown element mass number 16 63 and neutrons in it are 34. Yes. Now you have to calculate the number of protons, and they have given you the mass number as well as the neutrons. How you will do this?
But
If you know what was the formula was you have
nucleon number minus
number of neutrons. Whenever you have number of neutrons, A minus Z, right? This is the formula. So now you have to calculate the Z. You can intershift this. This formula will become A minus N, right?
yeah.
What's the answer for this?
And it's 29.
It's
29.
29. Okay. Now, one more example. Like for example, you have. They can also ask you from the. You must know about these. Yeah, till krypton you must know by heart. Okay. Like they can just write the name of the element. Like for example, they can write. They can say that. What is the number of protons? How many number of protons are there in the magnesium? Okay. So you must know this. I will take a test on this as well. Okay. So on the third we can have in krypton. How many neutrons are there in krypton? Krypton is this. So
Krypton.
36 into 83. 36 and 83. I'm writing over here. Now tell me number of neutrons.
It's 47.
Okay, it's 47 and equals A minus Z 83 minus 36, that will be 47. Okay.
Yeah.
Now we will talk about the ions. In the ions, what is the determine the number of protons, neutrons, and electrons in the ions? How ions are formed?
And
Hmm.
when different, no, they lose electron.
When?
Loss or gain of
Yeah,
electrons.
ions are formed by the loss of electron from the atom. Okay, ions are formed by the loss or gain of electron from the atom. Okay. Okay, whenever the electrons are lost, which type of ion is formed?
Electron is lost.
When
A
the
cation.
electrons are lost.
A cation is formed.
Yeah. Cation, positive ion. Okay, positive ion forms when electrons are lost, and the anions are formed, negative ions,
The gain of electron.
by the gain of electron. Okay, now we have different examples. Like for example, yeah, just like I'm writing over here, calcium 2 plus. Okay, now in this you have to tell me the number of neutrons, protons and electrons.
Okay. That's calcium.
Calcium 2 plus. So calcium is the, that is for 40 and 20. This is,
Yeah.
I think 20 and 40. The mass number is 40 and the atomic number is 20.
Okay.
Firstly you have calcium 2 plus ion, right?
Yeah.
So now what you can do?
The nucleon number is 40. The proton number. The proton number is 20.
Proton number.
And
Why
and
20? It is plus 2 charge.
that's proton number doesn't change. The proton number doesn't change. I'm saying the proton number doesn't change.
Okay, yes.
The electron number will be 18.
The electron will be 18, yes. And neutron?
The proton number will be 20.
Yes, the neutron will be 20. Okay. And now one more example for you have magnesium 2 plus, and magnesium is 12 and 24. Its atomic number is 12 and mass number is 24.
Okay. The nucleon number is 24?
Yes, 24.
Okay. The nucleon number is 24. The proton number is, what was it?
12. It was 12.
Oh. 12? The electron number is 10.
Yes.
And the neutron number is 12.
Is 12. So 2 is less from the electrons. If we take the anion, the example of anion, like for example you have the chloride ion, okay, and chloride ion is 37, and that is chlorine, bromine, yeah, 35 and 17, 35.5 and 17. That is 35 and 17. This is 24, 12. This is 40, 20. Okay, now what is A for this?
A is 35.5.
Yes, 35.5. Okay. What is proton number?
It is 17.
17. What is electron number?
It's 18.
One addition of one electron. It is
Yeah.
18. What about neutron number?
Neutron number is 18.5.
18.5.
Yeah.
35 minus 17. 3. Yeah, 18.5. Sometime in some books it is written as 36. Okay, for this
Yeah.
is written as 36. But when you go for the advanced, you will see the 35.5. If they give you with the 36, if they don't give you, then go for the 35 or 36. You can do by both. It's acceptable because 35.5 is in between. Okay, and yes, this was about the proton, the ions, how we calculate the proton neutron. This was easy. You have done this, right? Till now you have done all
Yeah.
the things before. Now we will discuss the variations in the ionic radius and atomic radius. But before that, just recall all the things. I want you to revise all the things. Can you give a brief recap of the things which we have discussed so far?
Yeah.
Okay.
We did the structure of the
Structure of the atom.
structure.
Yes.
It is made up of protons, neutrons, and electrons.
Okay.
The protons have a positive charge. The electrons have a negative, and the neutrons are neutral.
Okay.
And the electrons have negligible mass, and they orbit the
Why we say their mass is
nucleus
negligible?
because they're light. No.
Because they are. You need to tell the value as well because it is written, and you must.
It was 1,000 something.
1836.
800.
1836 times. 1836 times. The mass of the electron is 1836 times less than that of the
protons and neutrons.
the protons and the neutrons. That's why we say that its mass is negligible. The mass of electrons is negligible. Okay, and what about this one? What I was telling you about this element and the symbol thing.
These are elements. Are pure substances that consist of atoms of the same number of protons.
Yes.
They're in their simplest form and cannot break any further.
Yes. And sometimes the elements can have same symbol, but there are different elements which have different symbols, and those symbols are because of their origin. It was iron. Who discovered the iron? That was maybe the person in the Latin. So that's why it is ferrum, and potassium is K, from Arabic alcolia or kalium. Okay. And lithium, Li from lithos. Okay, yes.
The charge on an electron is about equal to -1. And the charge for proton is about equal to
It's
+1.
not about equal to +1, but we say that when we compare charges, we say what I was telling you is that you have charge on the electron and you have charge on the proton, and this is the electron charge is -1.6 × 10⁻⁻19, and this is plus 1.6 into 10 raised to the power minus 19. You see the magnitude is same. The magnitude of the charge is same for electron and proton. That is why we are relating their charges. And when we relate, how we relate? We will relate in this thing, in this way, that the charge on electron is -1 and the charge on proton is +1, +1. You cannot say that this is equal to +1. We will say when we relate these two charges, at that moment we are saying that this is -1 and this is +1. These are the relative charges. These are not the actual charges. The negative charge, this one is the relative charge. Okay, this is actual charge is this. Actual charge is -1.6. And what about mass? Why I told you what I told you about the masses? Why we are comparing the masses for proton, neutron, and electrons?
Because the protons and neutrons.
Because I told you, subatomic particles. They are even, whenever if I put one dot over here, just this dot, this, in this dot, if you see this in microscope, at least you will get 1 million atoms in this dot. 1 million atoms. And in one atom you have subatomic particles. So those subatomic particles are very small. You cannot weigh them in grams. You cannot weigh them in standard units of coulomb on grams. So you cannot have the standard units for them. That is why, and why you don't have standard units, because they are very small. You cannot weigh them in grams. So what you need to do is you will relate their masses. You will relate the mass of electron, proton, and neutron. And how you will relate? By the thing that I told you, the protons and neutrons are having almost same masses. That is the reason we have given them the relative mass 1. The relative mass of proton and neutron is 1. And why is this so? Because we cannot weigh their actual masses, because they are too small. Are you getting my point?
Yeah.
Okay. And this is the way by which we come to know about the electron's mass. Why it is written like this? 1/1836. The mass of electron. The relative mass of electron.
Because
Why
it's too
we are
small.
writing like this?
That's the mass of
Electron.
because it is 1,836
36
times smaller.
It is 1836 times less than that of the mass of the proton and neutron. That is why we are writing it like this: 1 divided by 1/836. So in this way, when we compare collectively proton, neutron, and electron, we say that electron's mass is negligible as compared to the mass of electron and proton and neutron. Clear?
Okay. Yeah.
Okay. Then this thing. What is this?
Yeah. The A is the mass number. It's the number of protons and neutrons in the atom.
Okay.
And Z is the proton number.
Yes.
And the number of electrons in a neutral atom is the same as the proton.
Yes. And how we calculate the number of neutrons?
You calculate the number of neutrons using the mass number.
Okay.
You subtract the proton number from the mass number.
Yeah, from the total mass of the mass number. So you get the number of neutrons. And how you get the number of electrons?